Hello everyone, my name is Zhongjie. In this video, I'm talking about our DCASE workshop paper on improving the performance of automated audio captioning by integrating the acoustic and semantic information. Recently, automated audio captioning has aroused a lot of interest. We have 2 points to improve its performance. Firstly, we use pre-trained keyword encoder to enhance the ability of the encoder to recognize audio concepts. Secondly, we use multimodal attention module to utilize both acoustic and semantic information. The proposed model is shown in the right, and we will talk about 2 parts respectively. The first part is pre-trained keyword encoder. Firstly, we use PANS, which is pre-trained in audio site, to initialize the parameters of the encoder. Secondly, we build a feature hierarchy structure to combine multi-level features, which are obtained from the third, fourth, and the last convolutional block. Then, we extract keywords from the 5 captions of each audio clip to form the training label, which is a multi-hot vector. Finally, it is optimized by minimizing the binary cross-entropy loss. As for multimodal attention module, it utilizes acoustic features, tagging words, and previously predicted words. Acoustic features are outputs of the last convolutional block of the encoder. Tagging words are audio concepts that are recognized from the encoder. Previously predicted words contain all the generated words before the current time. The operation of multimodal attention module is following. Taking the acoustic information, for example, given the last hidden state and acoustic features, we use a addictive attention mechanism to get the attention distributions alpha of acoustic features in the time dimension. Then, the gated linear unit is applied to the output of the attention mechanism to get the final output. As for the semantic information, the same structure of the attention module is applied to keywords and the previously predicted words. Next, we add all of them with the predicted word of the last time step to get the hidden state HT. Finally, we use HT to predict the word in current time. Let's see some experiments comparing the proposed model with other models in Table 1. We could observe that our proposed model achieves the highest score on all metrics both in the cross-entropy and the side D optimization stage. In addition, the side D score of the proposed model improves from 41.9 to 49.1 after further optimizing side D. The ablative results of our proposed model are shown in Table 2. We could see that pre-trained keyword encoder and the multimodal attention module could indeed improve the performance of all the automated audio captioning. Finally, Figure 2 shows some examples of our proposed model outputs and the visualization for attention maps of the keywords and previously predicted words. We can find that semantic information is useful for generating the correct sentences, and extracted keywords may appear in different states in the predicted sentence. Attention maps of semantic information indicate that keywords and previously predicted words are constant to generate the current word. For instance, when the decoder is generating chirping, it pays more attention to the birds in the previously predicted words. but pay less attention to birds in the keywords. That's to say, previously predicted words and keywords are complementary to each other in the semantic attention module. That's all. Thanks for your listening.